Hi everyone, welcome to my channel. I am Dr. Shibas here. So in this video, I will demonstrate how to conduct and interpret Friedman test in SPSS. So we will conduct Friedman test with post-hoc comparison using two methods in SPSS. So the Friedman test is similar to two-way ANOVA with repeated measures. However, Friedman test doesn't require the normality of the data. Because free test is a non-parametric statistical test used to compare three or more related measurements. Instead, if we see my previous video on Kruskal Wallace test, where we compare the unrelated measures, but in Friedman test we measure the related measures. So we have example of 30 employees where we will measure the digital confidence of employees at baseline and after the immediate training and after 1 month. So you can see here we coded the data and we just put the label here. So we put confidence at baseline mean digital confidence at the beginning at baseline, and confidence post, confidence immediately after training, and confidence follow up, confidence after 1 month. So we coded the data as 1 to 5 ordinal scale. So it means these all three observations are interlinked with each other. I mean they are related to each other. So that's why we perform Friedman test in SPSS. Okay, so before performing the test in SPSS, we need to confirm the assumptions, criteria, and the other threshold values for free test. We go to our PowerPoint presentation. So if we see that what you will learn from repeated measures designed to complete report. Choose, recognize 3 plus related conditions or type. As you know, in ANOVA, we must have 3 or more categories. So in this way, we apply ANOVA. So this is similar to ANOVA test, but it doesn't require normal. So also we will use in SPSS related sample or non-parametric test. And Friedman test compares 3 or more related samples, not unrelated but related samples. Okay, we use it for repeated or matched measurements, related conditions like same people at 3 plus times, rankable outcome, ordinal or continuous because we have ordinal scale. And we will answer this research question: does at least one condition tend to produce different value from others? So if there will be independent groups, then we will use Kruskal-Wallis test. So you can see my previous video on Kruskal-Wallis test where the groups are independent. But in this data, the groups are related to each other. So that's why we are using Friedman test in SPSS. So we have ranked the observations at baseline, post, and follow-up. And check 4 assumptions before running the test. First one is related observation. So definitely the all 3 observations are related. Independent blocks, participants are independent of one another. So, and 3 or more conditions, all conditions are represented for each case, ordinal or continuous variable. And these are the threshold values. You can see omnibus alpha value should be lower than 0.05. So it means this is omnibus alpha value. So our p value should be lower than 0.05 so that we can confirm the rejection or acceptance of null hypothesis. Degree of freedom, pair count, and this is the most important Bonferroni adjusted significance level. When we divide the alpha by 3, we will get the Bonferroni adjusted significance level as it is 0.0167. So we also confirm that is it p value lower than this adjusted significance level or not, because we will in this way we will accept or reject the null hypothesis. So next one we will calculate the Kendall W power by formula, and we will see if there is a small improvement, moderate improvement, or large improvement and sample size. So this is basically a Kendall W power formula where we will calculate the small, moderate, or large improvement. So we will come back to our data set and we perform the analysis in SPSS. So we go to analyze, then click on non-parametric test, legacy dialogues, and then click on K related samples. Okay, so we will put the data in sequence. Like first of all, we put digital confidence as baseline, then immediately after training, and then confidence after 1 month. Click on statistics and descriptive, and then click on continue. So there is a default Friedman test, so we will apply this test, and we can also click on Kendall W power and click on OK. So we can see here the digital confidence at baseline mean is 3.57 and confidence immediately after training is 4.57 and confidence after 1 month is 5.43. So it means descriptive statistic results showed us consistent increase in confidence from baseline to after month. And when we see the mean ranks under Friedman test, we also see that the mean rank was 1.15 at baseline, 1.95 immediately after training, and 2.9 after 1 month. So it means confidence was lowest at baseline and highest at confidence after 1 month. So it means there is an increment and there is a large improvement. Okay, so we also see the significant level, which is p-value is 0.000, which is lower than 0.05, which is our criteria. You can see here. This is alpha value, so our value p-value is lower than this one. So in this way, we reject the null hypothesis and we accept the alternative hypothesis because there is a significant improvement from baseline to after month. So it means there is a significant difference. Chi-square value is also 49.784. So in this way, we reject the null hypothesis and accept the alternative hypothesis. So we also see the findings from Kendall power. You can see also mean value at baseline and immediately after training and after 1 month. So there is also a significant improvement from baseline to after 1 month. And the Kendall power 0.83. As you can see, we have already calculated. This is the observed power is 0.83. So this indicates a very large improvement among employees from baseline to after 1 month. You can also see chi-square value is 49.784. So SPSS calculates it automatically. If you didn't find this Kendall power formula, so you can apply this formula and calculate the power, how much strength the independent variable affect the dependent variable. So we will divide chi-square divided by number of observations, multiply bracket number of treatment. There are three basically group minus 1. So we will get this value as Kendall W. So this is a very large value because it is also greater than this one. So it means there is a large improvement, very large improvement. So after doing the Friedman test using Kendall power, we also do the comparison using the Post-Hoc comparison in SPSS. So we go back to our data and we click on analyze, then click on non-parametric test and then click on related samples. So here automatically compare observed data to hypothesized. Yes. Then click on fields We have three observations, so we put sequentially. First one, the digital confidence at baseline, then immediately after training, and then confidence after 1 month. So we also see the setting automatically choose the test. No, we particularly choose the test, like customize the test. We need Kendall, coefficient of concordance, and Friedman two-way ANOVA by Rex. So we click on run. So we can also see the test option because we are using 5% significance level. User missing, if there is missing value, then SPSS is automatically exploded, but we don't have. So we will click on run and SPSS provide the results there. Okay, so we can see here as per our p-value, when we compare the comparison and we see that there is a rejection of null hypothesis in both cases. So first case is because we are comparing the baseline with the immediately after training and then the baseline with after 1 month. So you can see here the distributions of digital confidence at baseline, confidence immediately after training, and confidence after 1 month are the same. So it means the null hypothesis declared the same, but our value shows that there is a significant improvement from baseline to one after 1 month. So there is a significant improvement and there is a significant difference. So it means we reject the null hypothesis. Another case, the distributions of digital confidence at baseline, confidence immediately after training, and confidence after 1 month are the same. So this is also not same. So both in case of Friedman test and in case of Kendall power formula, we accept the alternative hypothesis, we reject the null hypothesis because there is a significant improvement from baseline to after 1 month training. So we double click on this table and we get the results. Okay, so we can compare the things here. You can see a related samples Friedman two-way analysis of variance by rats. Okay, so you can see here the mean value, the mean rank is 1.15 at baseline, 1.95 at immediately after training, and 2.9 confidence after 1 month. Total number of observation 30 and test statistic chi-square value 49.784, and the p-value is significant because it is lower than alpha value and it is also lower than Bonferroni adjusted significance level. So in both cases the value of p lower, so it means we reject the null hypothesis because there is a significant increase in confidence from baseline to after 1 month. So we also see the continuous field information and pairwise comparison. So you can see there is a comparison of pairwise grouping data. You can see like digital confidence at baseline 1.15, confidence immediately after training 1.95, and confidence after 1 month 2.9. And in all three cases, we compare the sample 1 with sample 2. Like digital confidence at baseline to confidence immediately after training. So if we see the digital confidence at baseline and immediately after training, we found the chi-square value negative minus 0.800. So which is significant in case of alpha and also significant in case of Bonferroni adjusted significance level. So in this case, we reject the null hypothesis. If we compare the digital confidence at baseline to confidence after 1 month, so we also get the chi-square value, and in both cases the p-value is significant. So in this case also we reject the null hypothesis. So third condition is confidence immediately after training, confidence after 1 month. So this is the chi-square, and value in both cases also significant because the both significant alpha value and the adjusted significance value as per Bonferroni is lower than in both cases. Omnibus alpha and Bonferroni adjusted significance level. So it means we rejected the null hypothesis in all three cases. So we simply conclude the findings that there is a large improvement from digital confidence to immediately after training, and also there is a large improvement from baseline to after 1 month, and there is also a large improvement from immediately after training to after 1 month. So in this way we apply the Friedman test in SPSS in two ways. First we test the Friedman with Kendall power, and we also compare the groups by using the pairwise comparison, post-hoc comparison. Thank you for watching my video.